Okay. So the second presentation is about connecting SMW to statistical data, and this was done in the SMART project. And SMART is about sustainable management of available water resources with innovative technologies, and it is about integrated water resource management in the lower Jordan Rift Valley. You can imagine that there are a couple of problems with that. So first of all, the Jordan doesn't bring much water, and secondly, Palestine and Israel and Jordan, they don't talk too much with each other, but they need to, because otherwise it will become a really huge problem with water. And what we do, I mean, SMW is still a very small part in it, so mainly we are building wells and springs there, but at least we try to have scientists and decision makers collaborate and share knowledge to improve this situation. It is really difficult, but it is interesting. And what they have is, first they have Dropedia, which is a semantic media wiki, and they have the SMART database, which contains all the measurements that are made in a certain region. And Dropedia is, we are using semantic forms, semantic maps, result formats, rich media, and some more extensions. And there we store locations as springs, wells, monitoring stations, cities, and so on. They are put in manually, which is not a nice thing, but this information is not really available in structured formats. And then secondly, we've got the SMART database. It is an Oracle database which is storing statistical data. It has a kind of complex schema. You are not supposed to read that. I probably would not even have the legal allowance to show this, but it is a really complex schema. For example, we have the precipitation in Ira Meteo from 1986 to 2006. And our recent work was concerning to connect this Dropedia SMW instance with SMART database. And the question is how to collaboratively analyze data inside the SMART database using Dropedia. Again, here it's going a little bit technical. I will basically focus on two parts. The first is the linked data wrapper of an XML interface to the Oracle database, because the Oracle database, the SMART database, is not put on the web, of course, but it is put on the web through an HTTP interface which only allows certain queries and which gives you the information as XML. And then we have put on top of it a linked data wrapper, and then we query it using the Spark extension from Denny, where Jérôme has talked about yesterday, and I will give a short example of it. So the linked data wrapper is, we use Google App Engine for that, to transform the XML from the HydroSmart, that is this this is the interface to the Oracle database, and provide it as linked data. So we give locations and location data, we give them URIs, we allow access through HTTP, and we return the information as RDF. As an example, you see on the left side, and the schema you see kind of in the left side, and the most important part is the location data, which is the actual raw data that we need to talk about. So for example, you've got the unit of measure, some length maybe, and the date when it was, and the value, the actual value. And this is how it looks in Dropedia. So we have this Spark extension. The Spark extension allows to query a Spark endpoint. And for the Spark endpoint, we use qcrump.com. And qcrump.com is quite cool in this case, because we just tell it what RDF files we want to query. And this RDF file is depending on the ID code of the actual page. And then we dynamically retrieve the RDF from the linked data sources and can have a Sparkle query on it. And here we are basically querying the time series and the values. And they are shown here as a JavaScript. And you can have several different visualization formats with Spark. So I kind of like it because it's very lightweight and it's easy to use. Oh yeah, that would have helped. Exactly, so date chart visualization. So here you define the visualization. Here you call the QCRUM, but you could also use some other Sparkle endpoint. This is the Sparkle and the variable. And the current work is, so the actual status is that we can have simple analysis possible inside Drupedia. So we can have this visualization, and then we can just make the scientists collaborate and discuss about these visualizations. The problem is we want to have more complex analysis. We want to have a kind of more Excel-like analysis, because every time they want to change these queries, they need to do it with the code, and even if we wrap it inside a template, it might not be as nice as, it might not be that nice. So what we actually want eventually is kind of interactive, navigational, operational analysis in a way. So we want to view the data, these single facts, these single statistics of having a certain measurement at a certain location at a certain time. We want to view it from different angles first, so have dimensions. We want to have measures aggregated. So for example, this is not a good example in this case, but we could have the average temperature over the year, for example, which is not possible at the moment because this information is basically not stored in the database. We only have the raw data. Also, we want to have kind of drill down and roll up maybe some changed granularity of the information. So we want to view all the temperature for the whole Jordan region and not single Jordan cities. And we want to slice and dice the information, filter for certain years or certain locations. And so what we are currently working on is to provide a visualization that does that. And okay, I try whether that works. So the internet was okay. What you see here is this kind of pivot search we could provide inside the semantic media wiki. Oh. Thanks, Andy. So what we are interested in, we are interested in the different. So we show you right here, but this is a prototype. So we are interested in all the different measurements. So we just select the different measurements, and then we want not this count of the measurements, but we want the mean. So the numbers are updated here. And now we want to see the values over time. So we are interested in the time region. And so we see all the different analysis objects, so the measurements over time. But this is not very nice to see. So we drag this here. And so we have all the different measures over time and with the mean values. And then we can, for example, have a chart of it, and we can compare these different values. And for example, we could remove one, get some less values. So this is a kind of interactive analysis and more Excel-like. And this is quite an early state, but we want to have this possibly to have maybe use one of these views and then make it static and then store it inside a page and then make people discuss one certain stage, one certain, let's say, drill down to a certain granularity and then talk about it. This is what we would like to do. And thanks. Any questions to Drupal?
I didn't hear it clear. Where did you store the data?
In this case?
Yeah, in the Drupal case.
Yeah. The actual raw data stays inside the Oracle database. Because what we only do is we get URLs from the Oracle database, which gives us actual values through HTTP in an XML format. We could work directly on the XML, but we don't like that idea. We want to work with RDF, so we have written an RDF wrapper to the data, so that the data is just dynamically transformed into RDF. Then it is quickly put into a triple store, so that we can query it with using Sparkle, and then it is visualized. And this pipeline is basically done every time. In QCrump, the service I used, there's a kind of caching mechanism. So if the query is called again after some seconds, then the QCrump hasn't changed, so it caches the value, because otherwise it would just take too long.
So the triple store just acts as a cache in this case?
Yeah, exactly.
In the QCrump example, you have been referring to the data source as the graph. Didn't really saw the source that you are accessing. It says from something here. Is this actually the data source, or is it something else?
This is because of the wiki syntax. We are not allowed to have certain characters, but this really is the source. This really is the source. This is a URI. No, this is not a URI. It's the data. So it's the RDF representation of one specific location data set, because each location data set has again 3 representations. It has a URI, then web, and data.
So my question is, because this determines the graph,
yeah,
and usually you go to one triple store and ask the graphs in this one.
But then you don't need it. It's just, this is QCrump specific, because you need to tell QCrump what sources to query. And you could have several more RDF files here. But if you query, for example, DBpedia, then you just have this Sparkle DBpedia, and then you don't need this from clause.
Okay, the endpoint is the first line.
Yeah.
I missed that.
So you only support one endpoint, right, in this case? Just one endpoint at a time?
Yeah. Danny?
What else?
Not together.
So, I'm trying to figure out where the unique value of SMW is coming in here versus, say, taking the same Oracle database and putting a standard reporting and analysis framework on the top, like Crystal or
Excel.
Even Excel.
Yeah.
Yeah, I mean, where is SMW providing something unique? So, I mean, if somebody said to me, "Oh, I've got a database, and there's some other information, like location information, and I need to do some quick analysis on it," probably SMW wouldn't be the first thing that comes to my mind.
This is maybe something. The reason is maybe more history, because they decided to use SMW independently from the Oracle database, and they first of all wanted to share knowledge over Drupal. So put in informal information, annotating the information, being able to query it. But we had quite some problem with creating an ontology and some structure that the scientists really like, because they cannot really work with the wiki syntax. We need to create forms all the time. So we were looking for some added value. Yeah. And this connection to the database would maybe provide this added value, because the current access to the Oracle database is quite a hassle. They don't really provide good, they're very slow, these other web interfaces, and of course it's not nice to do something against them, but I mean, it's just a nice integrational work, because otherwise they would just use the access methods the database provides, things that you just mentioned, and Wikipedia, but we want to have a kind of integration.
Isn't it that in BI it's like struggling to get the non-structured just mine data and then harvest data from databases together. So I see anywhere in VR that this is a real problem. And I think that the value here is that you can add like textual information and just people can add things to it, and underneath there is the database.
Well,
right?
I mean, that's what I would have expected the answer to be, but that's not what Benedikt was showing, right? I mean, he was showing you a pure analysis link.
The reason is that we are right at the beginning, so what we want to have is this real combination. So at the moment it's about querying, about first, I mean, this is what I've shown. With BERT or some of these tools you mentioned, I think we could have made, or even with XOV, we could have made much bigger, better things. But this is one way where how we can include it into Dropedia, and then we can build something with it.
So do you see a sort of a collaboration framework emerging out of this? You know, something which would have these kind of neat wiki consensus and group authorship properties and so forth?
We will see how is it possible, how people can collaborate with these visualizations. I'm not sure. Maybe they don't write anything into the wiki after seeing any of these graphs either.
But then you know.
I don't know, but we will try that out.
Speaking of the reporting stuff, is that all newly created software for doing all the reporting, all the display and graphs and stuff that you were showing, or is that some sort of third-party tool? Yeah.
Yeah, this is good. What I didn't program this for myself. This is the Open Virtuoso JavaScript framework, and I kind of used that and made it ready for being used with Spark. So it is just a new visualization format for Spark, and it can also be used for visualizing other things. Yeah.
So which version of Oracle database are running? I know Oracle had like 11G. It has Spark, a triple store, right?
So
yeah, artifacts. So Oracle's database, like they're version 11G, and supports Spark. It has triple store.
Yeah.
And it's supposed to be high performance.
Yeah. We have talked about they are from the UFZ, these environmental information systems. I think from haven't done my homework. Yeah, they have different centers. I'm not sure where the database is stored actually, but I know they are not too keen on semantic technologies yet. So if I come to them, use RDF, now it doesn't work. So this was our way to use semantic technologies without disturbing them. I just told them, please give us some HTTP interface. XML would be great, and they did that. And on top of it, we could do the RDF thing.
So they outsource the data analysis to you guys, basically. Cool. And by the way, the visualization, the Spark thing is very impressive.
Yeah, it is very
Thanks. Any more questions? Great, cool.